All right, so what do we got here? This is the 7.7 homework. You're supposed to determine if a sequence is geometric, arithmetic, or neither. If it's arithmetic or geometric, you write the general rule. And I guess for some of you, what might be important is like, how do I know? How do I know? Because I stink at math. All right, so if arithmetic, we have a common difference. Plain and simple. And some of you do stink at math. So 216 take away 36. I'm looking at number 2, by the way, is 180. Now 36 take away 6, which is the next term, is not 180. It's not arithmetic. All right, so I know it's not arithmetic, so maybe it's geometric. If geometric, your ratio is going to be the second term divided by the first term, and it must equal the third term divided by the second term, and so forth. That's how it is. So again, pretend I'm bad at math. If I take 36 and I divide it by 216, I convert it back to a fraction. I should get 1/6. That was the second over the first. This pattern should hold. Like 6 over 36 should be the same thing. Notice the decimals line up. And then 1 over 6 should be the same thing. So this is definitely a geometric pattern. So I've decided it is geometric with a ratio, which we call R, equal to 1/6. Please use fractions and not decimals. And I'm supposed to write the general rule. So your form for the general rule is a sub n equals a of 1 parentheses r to the n minus 1. And I just plug some crap in. And we have to do recursive C with this too, man. I just remembered that. A whole lot to do. Anyways, the nth term, a sub n, is going to be first term, 216. Here's a sub 1 right here. First thing I see. Times a ratio of 1/6 raised to the n minus 1. And there you go. The state of Tennessee might do like some crazy multiple select. They might question, can kids do they understand exponents? Remember that whole n minus 1 thing? That would be equivalent to dividing the whole thing by 1/6, which is equivalent to multiplying the whole thing by 6. Crazy, huh? I'll call it exponents. Anyways, what would that be? That'd be 1296 times 1/6 raised to the n minus 1. Sorry, just the n. I don't know if they will or not. Sometimes they test these questions by looking to see if you can manipulate exponents. Number 4 looks to me like it's geometric. What do we start off with? Start off with a 32nd. We're dividing that by a 16th. Oh, sorry, I did that backwards. Forgive me. We take a 16th. We divide it by a 32nd, and we should be getting a half. Again, the only reason I'm pushing buttons over here is for those of you who just really stink at the mathematics. You also happen to be the ones who will not watch this stuff. You'll just get a Snapchat from somebody else and complain about how hard algebra is. It's 2. I said a half. It's 2. Apparently I stink too. But yes, that's what's happening. We're actually doubling the fraction. It's actually getting bigger and bigger and bigger. So your ratio here is 2. Your first term is 1/32. And it's time to write a rule. The nth term is the first term of 1/32. Be interesting to see how many of you guys write it like this or how you actually write it properly. I'll talk about that in a second. 2 exponent n minus 1. Now, you should not be writing with a pencil the way I'm typing this. If you are a blind copier. Can't even spell blind. The reason I'm typing is to make it more legible for you. But if I had a pencil and paper, this would be written 1/32 2 to the n minus 1. That's how it'd be written. Plain and simple, that's how I'd be writing that. All right. Write a rule for the nth term of the geometric sequence, then find ace of 10, and I have number 7 highlighted. So here's what I know. I know that the nth term, it is geometric, is first term times the ratio raised to the n minus 1. And I happen to know ace of 4 is 500, and the ratio is 5. Since I'm talking about ace of 4 here, I know that n is 4. So I'm just going to plug crap in. Plain and simple. The result is 500. It happens when I have a ratio of 5 and I have an n value of 4. So 500 is equal to ace of 1 times 5 cubed. And we all know that 5 cubed is 125. If I divide out the 125, I get 4. You probably don't believe me. You're like, man, what kind of magic is he doing? What kind of voodoo is this? The man can multiply and divide. What is that? It's 4. Usually I can. So now I can write the rule and find ace of 10. The rule would be that the nth term is the first term of 4 times the ratio of 5 raised to the n minus 1 power. And since I want ace of 10, I'm just going to plug a 10 in. And it's going to be a big number. There's nothing new about that. 5 to the 9th is pretty good sized. So I'll go over here and push some buttons. We got 4, parentheses, 5, close parentheses. I'm going to go ahead and do 10 minus 1 in my head. Pretty confident about that thing. Where we got 7,812,500. And that's how you do 7. These are very similar. Here we're given both terms, but the first one's kind of a joke because you got the first term. And again, we're going to use ace of n is ace of 1, r, rooftop to the n minus 1. Notice I just keep writing this thing down. You write it till you memorize it. I actually have everything but r. I'm going to talk about ace of 1. It's 1 equals, oh, sorry, ace of 1 is 1. I'm just going to plug this in, just like I did on the previous example. 625 equals 1 times r. N is that 5 right there. So rooftop to the 5 minus 1. So 625 equals r to the 4th. Switch over to pencil and pen here. The opposite of the 4th power is the 1/4 power. Now, you're going to be surprised at this, but the 4th root of 625 is 5. Ta-da! So r is 5. And again, your goal was to write a rule. So now you know the ratio. The nth term is the first term, which was 1, which would be understood. I'm going to put it there anyways. The ratio is 5. to the n minus 1. All right, 11. Again, writing down that rule. And I'm going to plug some crap in. And when I talk about ace of 4, I know n is 4. When I talk about ace of 7, n is 7. So I'm going to talk about ace of 4. It is 162. It would be equal to the first term times r raised to the third power, because n minus 1 is 3. Now I'm going to talk about ace of 7. It is 4,374. It would be equal to the first term, and 7 minus 1 is 6. What I'm going to do here is I'm going to solve the system. I'm going to solve one equation for ace of 1 and then plug in. Not a hard skill. 162 over r cubed is ace of 1. So divided by r cubed. Not a leap of faith there, kids. And I'm going to take that crap and I'm going to throw it right there. 4374 is equal to 162 over r cubed times r to the 6, which is already there. Now, when I divide like terms, I subtract exponents. So 4374 equals 162 r cubed. I'm going to divide out my 162. Check myself too, because it's pretty early in the morning. You can look down there at the clock, 6:37. 27. 27 equals r cubed. And again, the opposite of cubing is cube rooting. You can use exponents if you want. But the cube root of 27 is 3. Now, I also need to know the first term. So this is 162 over r cubed, 3 cubed, 27, which should be 6. So the first term is 6. Now, I'm going to use this rule. The nth term is the first term 6 times a ratio of 3 to the n minus 1. And there is my final answer. And there's all that beautiful work. All of it. It's beautiful. Learn how to do it. All right, the nth term of a geometric sequence is given. Find the sum of the first 10 terms. Show your work. Definitely see if it can be written as a fraction. And it may or may not. Sometimes to make things a fraction, you actually have to do things by hand. But here's my formula. My first term is 12. My ratio is a third. And I'm just going to plug in. The sum of 10 things is going to be 12 times 1 minus the ratio of a third to the 10th power, sitting pretty over 1 minus a third. Well, by the way, over here it says you need to find the first term. Ace of 1 happens when you plug in a 1. I know, it's amazing, right? Some of you have no idea how to do that. It blows my mind. You shouldn't talk crap. Not everybody was made equal. And the truth is, me talking crap probably turned you off from the subject a little bit. But it's what I do. I'm good at it. Notice how I'm typing in this calculator, because I didn't feel like going N over D again. And if I don't know what 1 minus a third is, shame on me, but whatever. Ah, it did it. Gave me that funky decimal, I converted it to a fraction. 118,096. Sitting pretty over 65, 61. All right. 16 is find the sum of the 4th through the 10th terms. Now, the number of things that I have is going to be 10 minus 4, add 1 back. 7. It's actually what I'm actually doing. I'm finding the sum of 7 things. The first term that I care about this guy is a sub 4. And a sub 4 is found by plugging in a 4. 4 minus 1 is 3. A 2 cubed is 8, so this must be negative 8. Negative 32. And again, I'm still going up top. I'm going to use this formula right here. But I'm going to use negative 32 as the first term. I hope that makes sense as to why I'd be doing such a thing. And I'm finding the sum of 7 things. The sum of 7 is the first term, negative 32. Parentheses, 1 minus, the ratio is negative 2. I'm going to put that in a set of parentheses. 2 to the 7th, sitting over 1 minus a negative 2. And I'm not going to judge you if you don't change or take away negatives, because I never do. A lot of kids don't understand that that's a positive. I mean, it's a lot of kids. I bet 10% of the student body I teach does not realize taking away a negative is a positive. And that's a true stat based on one-on-one experiences, but I put money on that. I bet 10% of juniors, let's at least say forget, which I don't know how you do it, taking away a negative is a positive. Blows my mind. Let's see here. Math, num, n over d. 1 minus parentheses, negative 2, rooftops to the 7th power. Denominator, assuming I don't realize that's 3, is 1 minus a negative 2. And closing the parentheses on this is optional, but just looks better. Negative 1376. So the sum of 7 things is negative 1376. Moving forward in my life. Find the sum of the infinite geometric sequence S of n equals a sub 1 divided by 1 minus r if possible. If not, state why. Now I'm told this is geometric, so my ratio has to be the second term over the first term. So here it's going to be a negative 2/9. Sitting pretty over 2/3. If you can't do that in your head, I still need to go over stuff like this. Because it can cancel those out too. Anyways, it's negative 1/3. But, you know, whatever. 5th grade math just belittles us, makes us feel dumb. Sometimes it does to me. I mean, I don't always get these things right in my head. And, you know, if you're the kid who doesn't know what that is, I just don't know. There you go, negative 1/3. So, is it possible? Since the absolute value of negative 1/3 is, let me rephrase that, let me erase that and start over. Since 0 is less than the absolute value of negative 1/3, is less than 1, this is decay. And the function converges on 0. Think about it. If you think about having a negative 1/3 to the x, this thing would flatline. It would have a horizontal asymptote. And that's what this is all about. We had that lesson. I don't know if that makes any sense to you or not. But I know that my ratio is negative 1/3, so I know it converges. And I'm going to find the sum of the infinite series, and it is the first term, 2/3, sitting pretty over 1 minus the common ratio of 1/3. Now I'm going to do this by hand just to show you it can be done. 2/3 plus plus, 1 plus 1/3 is 4/3, 3's cancel, 2/4, 1/2. I guarantee you I can do that faster on paper or in my head than I can by pushing buttons. But if I can't, it was 2/3 divided by, there's two things in the denominator, so parentheses, 1 minus a negative 1/3. Feel free to use N over D. Just takes longer for me to do it. 0.5. Who would have thunk? I was right. Who'd have thunk? 20 is a series defined by 4 times 6/5 to the k minus 1. So my ratio here is 6/5. And the theorem says if the absolute value of r is bigger than 1, the series diverges, which means it grows. And if you grow for infinity, you have no measurable, that's the thing, sum. So, since the absolute value of r is greater than 1, the series diverges. Hence, no measurable sum. The EOC stuff. This stuff is really important. And I'm switching off of ACT to this because, quite honestly, as much as y'all need to do well on the ACT, it means more to me that you pass your EOC. Solve the following logarithm equation for x. This one is so simple. This is straight up log is bay. We have a base of 2, an exponent of 5, and it equals 3x minus 1. 2 to the 5th is going to be 32. That's where it is. We're going to add 1. 33 is 3x. And divide by 3, and our x value is 11. 24. 3 high school students are trying to determine what proportion. Oh, by the way, this is the work. Three high school students are trying to determine what portion of households in their community recycle. Student A surveyed 25 of his family members and closest friends. Here's my work. This is biased. It is only talking about his family and friends, and they probably have similar opinions. Student B divided the community into 5 equivalent sections and randomly surveyed 5 households from each section. That's good. Student C surveyed the first 25 people who walk into the local mall. This is also biased. It has only mall people. And I know you may not believe this, but not everyone goes to malls. And is likely to have a higher percentage of people that live close to the mall. Now, the real answer on this one is B. B is what we call, and I haven't forgot a word, I'm so tired, systematic and random. randomness reduces bias. Write that. So it's those two. Most reliable is B because it's random. Function notation. Oh, y'all stink at this. You really, really stink at this. Anyways, I'm finding f of g of x. Oh, just by the way, I need to rewrite. It's the same thing I need to put on your basics. It's harder function composition. I'm still trying to get y'all past numbers. I don't know what to do. All my years, I've never seen a group quite like this one. Everywhere I see an x, I'm going to put that in its place. So there's an x that's squared. It becomes 4x minus a 10 that's squared, plus an 8. There's an x, becomes 4x minus 10, and then minus 20. If I want to square something, I write it twice. It's going to give me 16x squared minus 40 minus 40 minus 80x plus 100 plus 32x minus 80 minus 20. So ain't A, ain't D. If I put these two together, that's negative 48x. There Did I screw up somewhere? Oh, I didn't mess up anywhere, did I? Because this is minus 100. Those cancel. Just went brain dead for a moment. It's choice B. Almost done. Solve the log equation. We're going to condense. This is a log base 5 of 2 times x minus 3. And it equals log base 5 of 4 squared, because I'm allowed to move exponents up top. And we condense addition with multiplication. So since I have a property that says if log base b of x is equal to log base b of y, x is y. I was really disappointed in the number of you kids who understood that concept. Like, it was bad. That's usually a 90-95% concept that kids get, and it was like less than 50% this year. So anyways, according to that property, 2 times x minus 3 has to equal 16. So 2x minus 6 is 16. Add 6 on the 22, and x is 11. 29 is a great way that the state tends to test to see if kids understand the double distributive property. Root 3 times root 2 plus root 3 times root 6 plus root 5 times 2 plus 5 times root 6. And this becomes root of 6. This becomes a root of 18. This becomes 2 root 5. And this becomes 5 root 6 still. And these two guys are alike. That makes 6 root 6. Oh, I wrote that one backwards, didn't I? That was 5 times root 2. Numbers sucks here, got me. But anyways, if I put these two together, I get 6 root 6 plus that root of 18 plus 5 root 2. This is not a calculator problem. It's not a non-calculator portion of the EOC missed by half the students in the state of Tennessee. From the least common multiple for the polynomials x squared plus 7x plus 6, x squared minus 1, and 2x plus 9x minus 8. So this is another one of these 5th grade math skills. And maybe you remember this, like what is the LCM of, let's say, 8, 24, and 42? I'm pretty confident it's 2. Might even be the only one. Because 2 enters all 3 of these things, and it is the least. All right? So that's the idea. The idea is to find the common factor. So we have x squared plus 7x plus 6. I'm going to work with that first. Factors as x plus 1 and x plus 6. We have x squared minus 1. That factors as x plus 1 and x minus 1. And then we have 2x squared plus 9x minus 18. 2x and x to make the x squared. 18 is 6 and 3. Plus 6 minus 3. That'll be 12x minus 3x. Well, this is a weird question. That or I can't factor this morning, which is also a possibility. Let's see, that's 12x minus 3x, which is 9x, negative 18. Does it factor differently? 9 and 2. This is a really bad question. Which are factors of the least common multiple? There is no common multiple. They don't have anything in common. Horrible question. Yeah, so this is just a flawed question. Well, this came from the state of Missouri, so do better in Missouri. I guess I could see maybe saying we have x plus 1 here and there, and then we have x and 6. I don't know what the point of this test was. I'm very confused by that. It's just a flawed question. And that's where I'm going to stop. Even smart people make mistakes.